Okay, at the end we just have a couple challenge exercises. We don't have the answers for all of them, but go ahead and feel free to give them a try. Okay, first let's start by comparing our model to some of the published research out there about global warming. So first, let's go ahead and click on this link here to take us to reports for some published data. And so when you click there, that takes us to this interactive climatology map put out by the University of Michigan. So if you scroll down here, you can see that there's a bunch of red dots, one for each city around the Great Lakes region. And so those are all where they took data for global warming. So you can go ahead and enter a location here to search. So for example, we can pick Columbus, Ohio. And then when we search Columbus, we can see that there's going to be a bunch of areas around Columbus where they took data. So we're going to pick this point right here. And whenever you click on it, it comes up with data for that location. So it'll come up with a PDF sort of like this that shows some of the climate information, temperature changes, and things like that. So if we go ahead and scroll down, there's a few data points here that are interesting to us. First, we have the changes in average temperature between 1950 and 2020. So this tells us how the temperature has increased due to global warming. So we can see here annually, Columbus has increased by about 2.8 degrees Fahrenheit. That's compared to the 1.4 degrees Fahrenheit that is global. We can see here that Columbus has actually warmed a lot more than the global average. So then if we scroll down even more, we see some more graphs. And there's one that's interesting to us with the growing season changes here. So we can see that this tells us how the freeze-free period has changed. So the freeze-free period is the period where you can grow crops. So that means if you have a longer freeze-free period, that means there's less freezing days. So we can see, if we want to see how this has increased over time, we can go ahead and compare, well, 1950s were a little extremely warm. So let's look at 1960, and then we'll look over here more towards 2020. So at the very bottom, we can see there's around 170 days in the 1960s, and that's gotten up to around 203 here near 2020. So if we go ahead and subtract those, that's about 33 days. So that means that since 1960, global warming has increased the freeze-free period by 33 days. So go ahead and compare that to your model, and we can see how well our model predicts this change.
So another way that we could improve our code is with challenge number 2. For this challenge, it explains how if you live in a warmer area where the temperature doesn't usually go below 32 degrees, we could check it with 50 degrees instead of 32. To do this, all you do is go in your code and type in tcheck equals 50. And then when you run the code, you can see here that it checks the number of days below 50 degrees instead of 32 that are missing. The reason why we use 50 degrees and why it's important is because mosquitoes are usually active when the temperature is above 50 degrees. So if we are missing days where the temperature is below 50, that means we will have much more mosquitoes.
Okay, now in this challenge, we're going to consider a location near the North or the South Pole. So previously, we had checked 32 degrees Fahrenheit, as that was the temperature at which fresh water will freeze. Now we're going to consider the number of days that are below 29 degrees Fahrenheit. This is the temperature at which salt water will freeze. You can actually see this for yourself. When you put salt into water, it'll lower the freezing point. And so that means that that water won't freeze until a lower temperature. This is also why we put salt on roads, so that there's less snow and ice, so that it'll be easier to drive. So now in this challenge, go ahead and set tcheck to 29 and run the code to go ahead and compare it to 32. Now, you might think that, okay, a 3-degree difference might not make much of a difference, but this is actually really important in areas where the weather is colder. So, for example, polar bears are really reliant on sea ice to move around, to take breaks, and to find their prey. So if temperatures are increasing, that means that this sea ice is going to be melting, and there will be less ice for polar bears. So that means that this is one species that could really struggle due to global warming. And we can go ahead and model that and see that for ourselves.
This next challenge talks about how the coldest days of the year is actually towards the middle or end of January rather than January 1st. To see this, we could go to accuweather.com. And then when you go to your location, you're just going to want to click on monthly, that you can see right up there. And then when you see here, it says July, or whatever month it is now for when you're watching this, we're just going to change that to January of 2021. And then if you scroll down, you will see here there is a little graph that shows like the temperatures from each day from that month. And we could see here that towards the end of January that the temperatures are lower than in the beginning. So now it is your challenge to shift your model about 2 to 3 weeks to the right to make this more accurate.
For the next challenge, we're going to modify our code to simulate a city in the southern hemisphere instead of the northern hemisphere. So what a lot of people don't realize is that when it's winter in the northern hemisphere, it's summer in the southern hemisphere. This is why they actually do a lot of scientific experiments in Antarctica in the winter months, like January, February, because that's when it's actually warmer there. So to model this, we somehow need to flip our numbers so that the warmer months now become the colder months, and vice versa. So just as a hint, you can do this by only modifying one line of the code.
So this last challenge allows you to look at weather from your location to make a more realistic assumption on the variability or the random function that we used. So if you remember, when we used the random function, we set it to from -10 to 10. So that made the highest jump of temperature from day to day be 20. Now, if you live in an area like here in Ohio, it's not really unusual to see the temperature jump from as much as 40 degrees. So it is your guys' challenge to look at the data. You can use AccuWeather or other resources to see what a more realistic variation of weather will be.